Hello everyone, this is Mr. Kozlowski and welcome to lecture 2C for Unit 8, and today we're going to be talking about chemical reactions and mainly how to do an atom inventory and balance them. So basically, students can conduct an atom inventory and use this atom inventory to balance a chemical reaction. So again, I've probably talked a little bit about this, and you should have some idea of what an atom inventory is and what you need to do to balance it. But basically, it depends on identifying parts of the equation and learning how to use them properly. So those parts of the equation in atom inventory, a few things. Obviously, you must know what the reactants and products of a chemical reaction are. If you don't know that, that the reactants are what we start with in terms of chemicals, and they are going to combine chemically to make a reaction. The product is the result of that reaction. Some other things with the parts of the equation that you must know are, again, coefficients and then also subscripts. Coefficients tell us how many molecules of each compound we have, and then the subscripts tell us how many atoms that we have. Now, with the coefficients, if we look at hydrogen here, we have two molecules of hydrogen 2, or H2. So that means how many atoms we have, well, that depends on the subscript. So what we do is we'll multiply the coefficient through each atom. So we take 2 times 2 hydrogen, and actually on that side for the reactants, you're going to have 4 atoms of hydrogen in this chemical equation. So again, knowing how to use the coefficients and subscripts properly will help you do an atom inventory. So with that being said, how do you do an atom inventory? And the very first question you have to ask yourself, is this chemical reaction balanced? And if you don't know, you have to do an atom inventory to figure out. So how do we do that? Basically, if we look here, all right, if we look at this chemical equation, what I like to do is this arrow sign usually in a math class would represent equal sign, but basically this means yield, or what is going to be produced as a result. So here we have the reactant side, we have the product side. And what you essentially need to do is use the subscripts and coefficients to count how many atoms are on each side of the reaction, the reactants versus products. So let's look at the reactants first. I know that I'm going to have carbon, I'm going to have hydrogen, I'm going to have oxygen as my atoms. And basically I have to count up how many. So if we look at CO2, carbon dioxide, here we have 1 atom of carbon. We know that because there's no subscript there. If there's no subscript, we can automatically assume it's a number 1 there. We don't generally write that in our chemical formulas, and you should know that. Hydrogens, let's look at hydrogens. We have H2O here, so we have 2 hydrogens there. And then oxygens, we have 2 right there because we have the subscript, and then over here we have 2 plus 1. We're going to have 3 oxygens in this case. All right. So that's the reactants. Let's look at the products. So again, we're going to have the same atoms on both sides of the equation here, the reaction, because again, law of conservation of mass states that matter cannot be created nor destroyed. So let's count them up. We have carbon. We have 6 in this molecule, C6H12O6. That's called glucose, plus O2. So that means we have 6 total carbon. Hydrogen, we have 12 here, none in that one, so 12 is going to be there. And then oxygen, 6 plus 2, 8 total. Now, the main question again, is this reaction balanced? And based off the atom inventory, it's going to be balanced that the reactants must equal the products in terms of number of atoms, in terms of mass. And as you can see, we have 1 atom of carbon, 6 of carbon on this side. So obviously the reactants do not equal the products. Hydrogen has 2 on this side, hydrogen is 12 over here, oxygen is 3, oxygen 8. So obviously we do not have a balance here. So how do we balance that? If we go to next slide, we have to determine if it's balanced and do the balancing itself. So if we look, if I go back to our drawing here, all right, if we look right there, we know that we have C1, we have H2, and O3. Here was C6, H, what was it, 12, and oxygen was 8. So now what we have to do is we have to add coefficients to the reactants or products to balance this out. So what I like to do is I like to start with the first one, and obviously that's carbon. So let's look at carbon here. What we do is we multiply this through. So obviously the reactants are a little bit short on this side compared to the products over here. So what I'm going to do is I'm going to put a 6 there, because 6 times 1 carbon, you're now going to get 6 carbons. Now, however, that changed up the amount of oxygen. So, because we have to take this, it's like saying the CO2 is in parentheses in math class, and distribute it through. So we have 6 times 2 oxygen. That's going to give us 12. Plus the one over here, that's going to give us 13. So 3 is gone. All right. Now, that leaves a little predicament of how I like to balance the oxygens usually last. So let's look at the hydrogens here, okay? We have hydrogen 12 over here, hydrogen 2. So let's put a 6 there as well. 6 times 2 is 12. And now they're balanced. So carbon and oxygen, or carbon and hydrogens are now balanced. However, the oxygens are a little bit tricky. So now we have, if we count this out, we have 6 oxygen here, 6 times 1, plus the 12 over here. That's going to be 18 now, okay? And basically, we still have 6 here, and 2 here. So basically, what we have to do is we're going to put a coefficient here because we don't want to change up carbon and hydrogen. So what we need to do is we're going to put 6 here. So 6 times 2 is 12 plus the 6 there. That's going to get us 18. Now this chemical equation is balanced. So I apologize for the writing here. So, but that's how you balance a chemical equation. So again, just to kind of review here, what do we need to know? Okay, you're going to use coefficients and subscripts to conduct an atom inventory. You must list all the different elements listed there in their quantities for both the reactants and the product side. Then you're going to use that atom inventory to determine if the reaction is balanced. It is balanced if both the products and the reactants are equal to each other in number of atoms. And then you're going to balance simple chemical equations by adding coefficients to determine the types of atoms on both reactants and product side in order to make the equation balance. You're going to get plenty of more practice on this. This is just one example. So again, please let me know if you have any questions, and we'll keep on practicing these skills in class. Thanks.